to get the material from GitHub? Nabel, great. Aiza, good job. You got the material. Sorry.
What about Jensen? Were you able to download the materials? Yes, okay. I think
Is it good?
Yeah.
Maybe this is, let's wait a little. 11:05. Then we can do that.
Yeah.
Because there is typically only two. Because the other one are like observers. Hmm? So, hi everyone. Welcome to our session today, Introduction to Functional Programming in R. So before we get started, I already asked the one who arrived here early. Was everyone able to get the material from the GitHub we shared last week on Friday? Please show reaction for those who didn't show at the beginning. I can see the same people. Witness.
was able.
Good. So it's already 11:05, so we need to get started. Whoever is not here, they will catch up on the way. So far, we shared the pre-workshop survey to understand the knowledge, attitude, and skills of you guys. We have currently we have 5 people who have responded. So please, if you haven't, you can do so. And I'm gonna just walk you through the response outputs and to show you how it looked like. So the first part, we have the pre-workshop knowledge, and we can see for example, for the first question, everyone has ever written a function in any programming language. So no one, everyone has experience of writing function in any programming language. So you can react on the chat, please, with the programming language you are familiar with. Which language did you use to write the function? If you have written in multiple languages, you feel free. We have also understanding between the function output. We have some of the people slightly familiar, very familiar, few of them, like, yeah, one of them, moderately familiar. So we don't have person who is not familiar at all. In this workshop, we will work mostly with DHIS2 dataset, and there was a question to understand if you are aware about this DHIS2 dataset, the data from the DHIS2 system, and we can see only one person is not familiar at all. Some of them, they have heard about it. Some of them are very familiar. Good. And we had the question about the block of codes, which was summarizing TPR, and you can see most of the responses are, yeah, they are correct. So it means you understand what the code was doing. In terms of attitude, we have positive attitude. Yeah, in terms of skills, and this is aligned with the first question, when someone said they have ever written the function in any programming language, you can say everyone got it right here. So for the default argument also, great job. Yeah, so good job, everyone. Thank you so much. And we already have 7 responses up to now. Thank you. To start, can you see my screen, for presentation?
Yes, we can see it in presentation.
It's delayed. So in this workshop, we are going to cover several things. And the purpose of this is not to go deep into like computer science things. We are going to learn things which are related to data analysis to simplify our day-to-day works, like automating repetitive tasks when you are doing data analytics or cleaning. I already mentioned the material was shared on GitHub, and everyone has confirmed that they were able to get the material, which is a good job. So in this presentation, we will talk a little bit about the motivation, like why we need to write our own functions, or why do we need the functional programming when we are doing our day-to-day tasks of data analysis. We are going to show you how to write your customized function, and then try to use the functions we define in different scenarios or inputs. Our facilitators today, we have Christina Miala and Neema Kathleen is going to be supporting us, and my name is Kokoda Smith. So before to begin with, because not everyone is aware about DHIS2 dataset, which we are going to use in many of our examples, I thought it is good to have one slide here to describe about it. So DHIS2 system is the National Health Management System, which is used by different countries to collect their health informations, and including malaria. because we are working on malaria, mostly we are using the dataset for malaria, but it could be used to capture the data for HIV, TB, and other diseases. So in the table you see in front of you is the malaria dataset, which is captured by, it is simulated, not the real. Don't be asking yourself what country is this. So it is simulated. So you can see usually the data from health facilities for each country which is using this system. They report their malaria informations monthly for each facility. For example, in Tanzania, we have Aga Khan, let's say Aga Khan Polyclinic. So it report every month of the year, what or what number of cases they had. In this case, we have confirmed how many counts were tested, how many they also these indicators are also broken down by age, under 5, over 5. So in this case, you can see we have confirmed for all ages and tested for all ages. And the way they collect this, for example, if you go health facilities, you get admitted, you get received in the admission, in the consultation window. They take your information there. Depending on your situation, you go and see the doctor. When you see the doctor, they you will explain how do you feel depending on symptoms. You could be a suspected case for malaria, and to confirm that, they will send you to the lab for being tested. So along throughout of these processes, they are collecting informations at each step, and this information are coming out as the indicators we see in this data frame. Confirmed, tested, and also they break down by age. So yes, confirmed, in this case, it is all ages because I trim the data frame. We have all ages and confirmed the other 5. Is it excluding?
The confirmed, so includes the data under the confirmed data.
Oh, sorry. My bad. It include the under 5 and over 5. We are just breaking up by treating the under 5 separately because of epidemiological reasons. Yeah. So it includes.
The presentations. Topic has joined.
Want to
If you
see
can
your
pause it.
sense of joining on that.
I think maybe you need to go.
You want to see people?
No. He wants to see your slides. If you go to that,
Yeah.
green rectangle.
You don't see my slide?
No.
Yeah, we are seeing it here, but not so.
Yeah, you need to join because otherwise it will be hard for me to switch. Yeah. So everyone is good here in the room. So the question here would be, if you are familiar with the DHIS2, depending on these indicators, what kind of metric can be derived from this table? Feel free to write on the chat. We have confirmed, tested, we have clinical indicators, we have OPD, consultations, all of those counts. What kind of indicators can be derived? Derived, it means you are calculating it from the other indicators. Yeah, you can tell me on the chat if someone reacted. Feel free to unmute your microphone and speak up. confirmed and tested. So let's say confirmed and test. Found the great from witness. Yeah, another indicator. So thank you for everyone who reacted. Hey, is my slide? So usually we have the TPR also. I saw some people say you can get over 5 by taking the difference. But there is one common metric which is called test positivity rate. If you and test positivity rate is the proportion of people who have tested and they were found positive of particular condition. In this case is malaria. So if you say positivity rate for malaria is going to be number of confirmed cases, for example, in this first row, divided by the test. So it's a proportion. If you have 100%, it means everyone who were tested, they were positive. Zero, none of them was positive. So with that understanding, this is gonna save us we go ahead with our presentation or lesson. So let's say now from this data frame, you have been asked to summarize this TPR for different levels. Remember, the data set is reported at facility level monthly, and you have admin 2 in it is equivalent to districts or councils in Tanzania. And you have admin 1, which is the major administration, the higher level administration unit, equivalent to region in Tanzania. So let's say you are calculating the TPR now using this data frame. At facility level, admin 2 and admin 1.
Can you have TPR for confirmed and applied?
Yes, because you have the variables for under 5 and over 5. For under 5 test and confirmed. It is possible to have. Yeah, please, you can answer them through the chat also, so that we don't waste time. So from the data frame you see, now imagine you are summarizing the TPR at facility level. You can see and this metric I forget to mention is usually calculated at a yearly frequency. The data was at monthly level. So to get the summary of TPR at facility level, you can check, you can use the group by health facility and then the year, and then you have these summaries. So this is at facility level. So if you want to calculate maybe in the second level now, at district level, the traditional approach you will copy and paste in the second level and then modify the variables which are changing. You can see for the last level also admin 1, you will copy and paste. You see, if you have many levels of doing summaries, the copy and pasting is gonna be too much. You will be copying and pasting, and there are things or caveats which are associated with this copy and pasting. So for example here, can you identify which parts of the codes is the remaining the same or which one is changing? the block of code which is varying and the one which is changing, which is staying the same. So I'm gonna help you. You can see summary from the summary for both 3 levels. You have summarized 3 times. The same block of code is repeated 3 times. 3 times. So we need to find a way how to avoid these repetitions. And the only thing which is changing here is the HF facility names, admin 2 names, and the admin 1. The rest of the code stays the same. So the reason why we are going to learn the function is to try to find a way which to minimize this amount of codes, to write the function which will be able to minimize this repetition of the codes. So away from the repetition, there is also one more problem. If you are copy and pasting this code and modifying, you can see here the TPR for admin 2, it was copied from the health facility level, but turn out you can forget to change the variable, the grouping variable. The same to here. You forget to change the variable which you are assigning. So all of these things, they are the reason why we should find a way to compact these codes into one function which can be applied repeatedly. So to break down for you to understand the 3 block of codes, we try to put them side by side here. You can see the first block of code, the TPR at facility level, district level, and regional level. And you can see the codes remain the same throughout. The only things which are changing are this grouping variable. In this case, HF admin 2 and admin 1. So we need to find a way to write this workflow or the block of codes and then use changing the grouping variable so that we can apply at different level of analysis. And this will bring us to the introduction of R, introduction of functions in R. And the function in R is the way to write the repetitive block of code so that it can help us to reuse it when you have similar situation. So by definition is the reusable workflow that can be applied to different inputs. So the workflow we are talking about is like the previous one we saw, the TPR summary. So you see how it was repeated through at different levels. So the functions, as we mentioned, that is a block of code which can be written once and then applied on different inputs to get the outputs. So the analog of function will be here. We show the analog of the functions, the metaphor of the function. Think of the function like something which is taking input and processing it and then hand over the output to the user. It's like when if you know the grinding machine, you put the like cones and then the machine is processing, you end up getting the flour in the end. The other thing would be like vending machine. If you understand vending machines, you put the money, you put the amount of things you want, and then that thing you want, let's say snacks, And then how the machine is working, it is mechanical incorporated in the machine. So eventually you get what you want as the output. The other analog is you can give on the charts. There are many analogs. So it's simply what is taking in, processing, and getting the output. And the purpose of writing function also is to encapsulate or hide the complexity of the codes which is happening in the function or when you are performing the task. So ever since you started learning R, you have been using functions in different ways. Maybe you didn't notice. So for example, when you are writing sum, printing, max, minimum, and so on, different functions. You have been using function, but these functions are the one coming with R. When you install R, they come, you can find them. And also there are functions which have defined by people for performing different tasks. They come in terms of packages. For example, when you install ggplot2 and you load, and every time you are calling ggplot function, you are using function which was written by someone to solve the visualization problem. The same way tidyverse functions. So those are the functions which are written by people and package it together depending on their functionalities, and then they help you to solve different problems. However, when you have not always you will face the problem which has a function to use. So sometimes you will find the situation when you have to write your own function. This is what we are going to learn. So can you react on the chat if you have used, you can write your favorite function you use? You have used so far. Just one. Print, witness. How about the others? You never use any function? View, good, Babalola. For viewing, for head, for checking the data frame, some few observation, paste for connecting to strings, mutate, yeah, different functions. But these functions have been written by people, and there are others coming with R when you install it. So we are going to learn how to write our own function in R. And that is the foundation of functional programming. So how do you write your own function now in R? We have the structure you can see here on the left is the general structure of the user-defined function. User-defined function is another term for custom function, or the function you write yourself, and it has the syntax. Like the way we speak language, there is a way you need to organize the function. So we have four main parts. The first one is you can see the function name. You need to give the function the name, and the name is like identifier of this function. It's like an ID. If you will see in the R session, when you create the function, it goes to the R environment or global environment. So to identify that function, you need to give it the name. And it is recommended to give the name which is descriptive. Like, let's say the function is adding the numbers. You can see on your right, we have an example here. So add numbers. So it has to be descriptive, like what, depending on the task it does. So you give the name, which is descriptive. So someone, when someone want to use it, someone else want to use it, they can easily understand. The second part is the function arguments. We remember we say it is taking inputs, different inputs, and return the output. So arguments are simply a list of values or inputs of this function. It could be 1, it could be 2, they could be even 100. Yeah, as many as you can. So in our example here, we are trying to add two numbers. You have two inputs, X and Y. The first number and second number. You could decide to add even 5 numbers by expanding the arguments. So we have the third part, which is body, the body of the function body. This is like engine of your function. It is enclosed in these curly brackets. So it's the logic now of the function, what it does. If it is calculation, for example, here you're adding two numbers in the results. You can see my pointer. Yeah, so this is the function body. So it starts from simple and it can be very complicated depending on the task you want to perform. But here we just show the basics. So we have the last part, and this last part is the return value. And it shows the end of the function after performing all the execution, and then it give you the results. This return value is not necessary to put, but it is a good practice to include it. So it's included in one of the four parts, but it's not mandatory. It's an option because the error just return the last expression to be computed. And also we specify you can also decide to use return when the execution is stored in the variable. Like here we store the results. So when you run this to return, to get the output, you need to specify explicitly return the results or whichever variable you have used. So to highlight the most important thing in R, we are using function keyword to tell R this is what I'm writing is a function. You can see I bolded it at the bottom here, function keyword. If you go languages like Python, they use diff. I don't know about other functions, Kaiser, for example, in C++, or if you are using, yeah. No need. Some languages, according to my expert here, some languages you don't need keyword. So, but at least for these popular languages, you can explore. But in our focus today is R, so we are using function. Oh, so that is a little bit introduction how to write the function in R, and we're gonna give like 3 minutes so that we of refreshing, and then we will head to the live demo to see on the codes how to write the function and use different function in different ways and modifying arguments and so on. I shared with you the material last week, and it includes one of the scripty, which is like a guide, intro function, something like that. So please show the reaction on the chat if you saw that script. It is our script. Slidian. At the same time, we are on the break here. We will come back at 11:38. So you can take a quick water or something to drink. Yeah. Please let us know if you are unable to see the script I'm talking about. Hmm? Hmm?
Yeah.
So, hi, David. Good question. A little bit of clarification here in response to Christina's on the chat. So yes, the function can have no argument. It is possible. However, in many situations, we have where we are specifying the argument, but you can decide to write the function, and most of the time they are the simple one. For example, if you want the function to return the same thing every time, like printing something every time, that function would not need to have argument. But if you want to vary for different inputs, so you need to have parameter which is varying in this case, the argument we are talking about. And this is the common situation. We'll have a different, you will apply the function in different situations. And that's the main reason why we are writing function. Yeah. Because you will have to change some arguments or parameter so that it can be used in different situations. But the bottom line, yes, function can have no argument. So I hope everyone is back. So in the meantime, please go and open the material we shared last week on your R Studio. In my case, I put them on my desktop. And in here, you can see we have these. Some of the files were not included because they are not for students. So please open this intro to functions. update my studio. I will bypass this. So is everyone able to get here where I am? Sylvia, how about the other people? Victor, Witness, Garrison, Babalola, Annabelle, good job. So if you are, everyone is here. So in this case, in this demo or live coding, we are going to cover some parts here. So we will have the example we have introduced in the slides. We will use it here to show you a little bit how tiresome it is to write the repetitive codes. So we will repeat the example here, and then we will start writing the function in R now. We'll try to write the simple functions and also give you some exercise to write by your own. And then we will try to modify the arguments or parameters, and then try to use a source function for using the function from another script or you have written previously. And finally, we will write the function which can solve our motivation problem of summarizing this. So to start, I would like you to load the library we are going to use in our analysis, which will help us in the data summary. And I think for easier, you just load Tidyverse, which is the collection of packages. You don't need to load many packages. So you can load Tidyverse. And then what am I getting? Conflicted package.
Hi, Kokoda.
Yes.
Yeah, it looks like when we load the tide reverse, every time we get this conflicted package, but it's still working.
Could
But
you
it will
repeat?
work. I said, it
Yeah.
looks like when we load it, tide reverse, every time we have this last message, but it's still working.
Yes, the reason is because Tidyverse and some other library still have some functions within them that are
Yeah.
the same. So what is just
Yeah.
telling is that whenever you want to use those functions, you specify which of the packages should load it. That's all.
Yeah. Yeah. Thank you so much for your contribution. So ignore this message you are getting. We can load the dataset we are going to use is stored in the data folder. In the data folder. So just load. I'm gonna call it df and then read. I will use CSV as a function. Let's make sure you are in the your working directory is like this, user functional programming. So you are in the folder which has all the materials. So it will be easier when you are reading your file. For example, here data. Then if you click tab, you will see the files, two files, encode missing and DHSXY malaria. So it's this dataset you can see here. And then I forget to clear the environment. So you can do so also if your environment is mess like this. So I'm gonna remove everything from the environment so that we can run from fresh. So if you run the code, you will load the dataset which has more than 60 observation or health facilities which are reporting monthly, and they have 21 variables. You can view them here. You can see the same data frame, similar data frame we saw on the slide. However, here we have many variables. So you have OPD, OPD under 5, we have confirmed under 5, all the way to clinical over 5 and under 5. So here for confirmed is confirmed for all ages. It means is the total of over 5 and under 5. The same apply to all other indicators. So what we are going to do now, we are going to calculate the TPR the same way we saw on the slides, the TPR summary. And the TPR is coming from the confirmed divide by test. And in this case, we are interested in TPR for all ages. The column named conf and test, not under 5 and over 5. So you can say TPR at health facility level. So you will give it the name like TPR at HF equal to DF, data frame you have, and then put the pipe operator to connect it to the tidyverse functions. In this case, we are calculating TPR by year for each facility. So you will have to group by health facility, name, and the year. So what it does, it will group all for each facility. It take the 12-month counts, and then depending on your summary function, it will compute those summaries. So in our case, we want to summarize across this grouping variable. So we want total confirmed cases, which is sum of conf. Use this variable conf. As you saw in our data frame, we had in each variable, almost each variable, we have these missing values. So you need to specify in the sum function how the missing value should be treated when you are taking the summation. Otherwise, it will give you the error. So you need to, there is argument here called in NA remove equal to true. You need to specify equal to true. So it means when you are summing across a month in a year for each facility, you need to remove the NNA or missing value. So we do the same thing for test. You just copy this and then paste, then just modify the test. Then put the test here. So after getting the total for each year, for each health facility, we want now to get the TPR. The TPR is equal to the total confirmed. Remember we said is the proportion of total confirmed cases to the total tests. So if we run this, You see, it will tell you has group D output by health facility. You can override using group argument. This is just a message. But to override this, there is one additional argument, but it's not necessary in this situation to turn this grouping data frame into a normal data frame. So you can view here our new data frame we created or grouping. You can see for each health facility, for each year, you have total confirmed cases in that year, total tested, and then you have TPR, which is the proportion of the two metrics. So we can do the same thing for at admin 2 level. So before we go for the second level, is everyone able to get here? I can see reaction from Taiwo.
I didn't.
Garrison, you didn't?
Yeah, I'll share on chat the coding.
Can you check on the chat, Christina?
Yeah.
So to do the same summary at the next level, which in this case is admin 2 level, you can copy, paste here. Copy, paste, and change just the assignment variable. In this case is admin 2, and the grouping variable is admin 2. And then only 2 places you have to modify. And then if you run again, you get is it not a small fix? Yeah, so if you take for the second level, you just modify the grouping variable and then assign a different name. So you can see the data frame, how it look like admin 2. You can see the same structure. Monthly, we have total confirmed cases, total tested, we have TPR in that specific admin 2 or district. You can call whatever you want in term, depending on the country you are working with. So the third summary, it could be we want TPR at admin 1. For example, in case of Tanzania, we want now at regional level, what the proportion of people tested positive from the health facilities in region like Dar es Salaam per year. So you see, you can copy paste it here and then modify the comment. In this case, we want admin 1 and then modify the assignment variable. You can see this copy pasting and modifications. It is easy to forget. And it's also boring, copying, pasting. Imagine you have a 10 administration level, you want to do the same thing. So if you run this, it will produce another data frame at admin 1. You can see the admin 1 is big. So you can see the total cases and tested are even more compared to the lower level, which makes sense. You can remove this from here and then save the file. So we saw what we saw in the slides by implementing it. You see how repetitive it is and how easy you can make a mistake. In a slide we saw if someone could not forget to change the naming here, somewhere they forget to change the grouping variable. So we want to learn how to write the function so that you can write these ones and then use the arguments which are changing to perform the same summary.
Okay, guess I'm trying to run your code and I do. You still find the same errors.
Sorry, I didn't get you.
So I run the code and it made errors. Do you still find the same error?
No, I can't hear properly. You are breaking down.
There's an opportunity to question, this is going to help to troubleshoot it.
I didn't really understand what you're saying. I think it's the report.
Yes, I can hear you now.
You know the time is fashion because it was like something it means you know
No, I can hear properly. I can hear what so you're breaking down. Yeah. On my internet. You can go ahead.
yeah, they give you some knowledge on the vector from the so can help you resolve. So everyone is there in the classroom. Can you hear me properly? Someone should be serious fast. So, oh, can you hear properly? No, it's not that nice. Oh,
Basically, that doesn't matter.
can you hear me?
Yes. No, but I can hear because you are like in a room, but it's really cutting.
Okay. It's
Oh dear.
But the thing is this, you see, seem like something.
Sylvian, can you hear us now?
Yes, now we could hear you well.
Now you can hear us well?
Yes, yes.
So you can just speak from this.
So, there is from here.
This is complete. Yes, sir.
No,
Sorry, guys. You're back. So I should still sharing.
Mm.
So that's not good.
Mm. Do you see something? Mm?
No, we can see this one.
So just to confirm, Gerson, have you been able to follow up to where we have reached?
How about here?
Yeah, we can see it.
You can see the arrow studio.
Yeah, we can see it.
Yes.
Gerson, can you put a thumbs up?
Yes, I did it until admin 1.
Yes, yeah, I can see now. Yeah.
So sorry everyone. Yeah, we had a little bit of technical issue here. So I believe everyone has got here where we have TPR calculation at my admin 1 level, right? Do they hear me?
Yeah,
Ask Sylvia if she can hear you.
just give us a thumbs up.
So as we mentioned, we are going now to see how to write our own function, and we'll start with simple functions. To recap, you can remind ourselves here the main parts of functions of user-defined functions. We have function name, function name. We have arguments or parameters sometimes. These are the things which are going to as the input of the functions. And then we have body of the function body, the one which is enclosed by curly brackets and is engine which is doing the execution or performing all the processes. And we have return output. The last part is the output, which is returned by return keyword in the function cal braces. So we will try to write a simple function to add numbers. Add two given numbers. So remember, we mentioned that you start with the function name and it has to be descriptive. So for my case, I will add numbers, and then just the way you are assigning variable to different values in R, you use the same for functions. So this function should perform, you connect the name with a backward arrow. And to tell R if this is function, you need to use function keyword. As you start typing, it should pop up here. And then you click enter autocomplete. and you will see the parentheses. In the parentheses, you need to put the arguments. In our case here is two numbers, any two numbers. So let's say I call number one A, number two B. After then, you need to put the curl bracket in, the curl bracket. If you click Shift and then you have on your keyboard curl bracket, it will give you double. So the good practice, you need to break another line for the continuation of function, the curl bracket in a new line. So you can see automatically the cursor is indented here, where you can see. So in the curl brackets is where you are telling R how do you add these numbers. So it could be addition, subtraction, division. You can do whatever you want in the curl braces. This is the body of the function we are talking about. So here you can decide to call to store your summation as results, or let me call them summation equal to A plus B. And then whenever you assign the summation in the variable, don't forget to use return a keyword. You are telling R now give me back the output which have been stored in the summation variable. So this is up to here, we already have our first function, which is adding the two numbers. And these numbers are represented by these arguments, A, B. It means any number, any two numbers, you are giving this function, they will be added. Which is why we are using the argument, which is varying the variable, the argument or inputs. So every time someone wants to use this function, they just need to specify the identifier, which is the name, and then supply the inputs, which in this case is A and B. So if you already have this function, something to mention here is you see the curl bracket, where the curl bracket ending, the last curl bracket is the end of your function. So whenever you run, it will run all the codes which are within this curl bracket. So eventually the final output will be returned. In this case is summation. So the function could be as complicated as possible, depending on the task you are performing. So if you are here, try to run. And if you run on your global environment, you will see when you have on your global environment section, environment, then global environment, you will see where we usually store the data, and then there will be another section created specifically for function. And you will see here functions. So why R has already identified this function, because we use this keyword function. So you see function is stored here. So whenever you define your own function, they come here. Even you define 100 of them, they will be available here. So is everyone able to get this addition? Sylvia, this is very easy. Garrison, Victor, Annabelle and Witness, Babalola, I have a Witness, Annabelle. So it seems like these things have done by many people, many of you. So now you already defined your function you want to use. How to use it? We are calling it. So you want to use for different inputs. So we are calling the function. Add one more comment here, use the add numbers function. So you can try to use it here. Add numbers. If you start typing, it will pop up here. Then it will show here at the top what argument they are needed. For example, if you run without supplying anything, you will get an error. That argument you can see at the bottom of my console, on my console here. Error in adding number, argument A is missing with no default. We will talk about default argument here in the later section, but you need to supply the arguments here. So you supply A, you can explicitly say A equal to 2, let's say B equal to 5 or 7. So let me change the comment here, add 2 and 7. So if we run here, you should see, I don't know, what is this? You get 9, you can see you are getting 9. The same thing, if you want to add, you can also specify, not necessary to use a keyword argument, like to specify A equal to, you can specify depending on the order. Like, A is the first number, B is the second number, so you specify 7. You see you are getting the same output. Make sure the order is what you are following the order when you are specifying these arguments. So you can try with different outputs, with different inputs, and get different outputs. So that is the basic of writing function for adding the numbers. You can also write for subtraction and many different. So another function, let's say we want to write the function which is printing something, like greeting, is giving greeting. You are greeting someone with their name. I want to make sure this, you can remember this. How do I make sure? I'm gonna put 4 stars, 4 hashtags, so that you know this is a new function. So let's say you want to define the greeting function. The one I just showed you, it was basic for mathematics. So let's say you are working with string now. Greeting, I will call my function greeting, and then function, put the name. Let's say you are greeting someone. Hello, Christina. Hello, Kokola. Hello, Kaiser. So I will give it the name here. The input will be the name, which is going to be varying. So here, you will see greeting. I want the function to print hello, name, and then combine the name with the hello. So I'm gonna use the paste in R, which is built-in function. Paste is 0. It is connecting the variable you are supplying, like a name, and then you have another string. Sorry, it has to start the greeting and then the name. So you have hello and then name. Try running this function. You will see it will get added here. Greeting, it has this name. Name as an argument. So if you want to greet someone, use or greet Kokoda. You can write your name here and then call the function greeting, then supply the name. You just need to supply the name, but make sure it is in the quotation, in double quotation, because you are in the body of the function, you are printing something which is connecting with the string. The name should be string. Otherwise, you're gonna get the error. So writing function, you need to also have some understanding of other functionalities in R. For example, this paste, it is for combining two strings with space as a separator, if I'm not mistaken. Oh, sorry. This one is not, yeah, it's combining hello Kokoda, but we need to specify in the paste function. This one doesn't have a default separator. So you can modify the paste, use the paste without zero, because that one, I guess it has space by default. So if you modify something in the function to change the behavior, you need to rerun again so that it's stored, it's updated here in the memory. So if you call again hello Kokoda, you can see now it is well spaced. Or you can change greeting. You see, if you were to greet many people, you don't have to write hello every time. You just need to specify their name. Let's say Osman. You say, hello Osman, hello Kaiser. Yeah, so is everyone able to get here? So great. So if everyone is able to get there, we have a quick exercise here. Can you break out room?
Okay.
Yeah, you will go to the breakout room and please write. Can you see my slides? Are they visible?
Yeah.
Yeah, so do only the question number one. Calculate write the function calculate incidence. This is the name of, should be the name. And we already have the hint here. The function which is calculate is simply calculating the incidence of maybe in the population. So you have cases and population is taking two arguments. And it will be 5 minutes, and then you come back and paste your function here on the chart.
The question has also been posted in the chat because the slides won't be visible in the breakout room. So if you could please copy that and have it with you. And we'll be opening up the breakout rooms now.
Yeah, it is strictly 5 minutes. Even if you are not done, you can come back. But we are encouraging you
Was this the
Is it Hmm? Was silence? Am I using your microphone or mine?
Oh, now it's yours.
So please, you can feel free to paste your function on the chat if you are back. We want to see what you have written on the chat.
Mhm.
I don't see any reaction on the chat. Yeah, I can see Sylvia, Victor. Good job.
One more group.
Hmm?
We're missing one group.
Yes.
Cancer Jason.
Gerson, Kaiser. Who is missing? Dawood.
The witness, Annabelle.
Abel, Dawood Witness, are you here? We are waiting to see your response on the chat. I actually gonna copy this. Paste it.
Oh, I was with witness.
Abel, Babalola, okay. Yeah, Babalola even make it more safe. He added additional controls. If there is negative population, there is zero population or negative, remove. Stop. Yeah, stop the population. Must be greater than zero. Yeah, you can. Good job. Thank you so much, Babalola. So you can modify the function however you want, depending on the control you want.
Yeah, how about Dawoodian witness?
Where are you with them?
Just broadcast back to the room.
Victor, I can't hear. Did you see their responses on chat?
We're discussing the chat. Share. Share some.
Are you looking for my response?
So I hope everyone was able to write the function like this. For those who added additional control, like the population to be positive, like what Babalola does, is good idea and it's the best practice. Sometimes you want to add more controls, but the basic function would look like the one here. I just pasted from one of your responses. So it could, if you have something like this, then good job. Sometimes you can decide to multiply by 100 by 1,000 here, so that it is population or number of cases per 1,000 population to normalize it. So the next thing we want to talk about is the default arguments. So we saw the arguments of the functions. When you don't specify, you are getting an error. let's say in here, we had this additional add numbers.
So that we
And
can see the screen.
we specify just 4. By default, by the order, this is going to be the value for the first argument. But if you run this, you will get an error that B is missing with no default arguments. So sometime you may
Kokoda?
you can
Cannot see your
specify
screen.
the default argument.
Kokoda, we cannot
Kokoda.
see your screen.
Calling the function or you are using the function and you didn't modify
Hello.
or
We can't
specify
see your screen. Can you
that
hear us?
It seems you
argument,
can't
the
hear
value
us
of
as
that
well.
function of that argument, the default value will be used.
And you can't hear us.
Oh,
The screen is not shared.
Kokoda, you can't hear us and we can't see your screen.
cannot see the link. Okay. How about now?
It's not showing.
Not shown.
Okay.
Can you see my screen?
Yes.
And they can hear you.
Can you hear me also?
Yes.
So perfect. So we are talking about the function with default arguments. In case you didn't specify one of the argument, the default one can be used. So let's say we are in our greeting function. Greeting function. We want to write another function, let's say greeting2 function, and then we specify the name as before, and then we want to echo this many times, like repeating the greetings. Let's say the argument called how many, then specify 3 times. This will be our default argument, and this is how you specify it. You define the parameter and then you give it the value in the parentheses. So let me change this to echo greeting. Echo greetings. So as usual, you use curly bracket and we can print now, paste, use the same function, paste hello, and then combine with the parameter of the function. Make sure what you specify in the parentheses is used here in the body of the function. So you use the name. Now we want to echo this several times. In this case, we have default value 3 times. Let's say we want to repeat this. In R, we use reap function, and is taking what you want to repeat. Sorry, I just wrapped up this repeat. Repeat. Then how many times? How many times? So it is printing hello, your name, and then how many times it should echo this. So if you run this and then use our echo greeting function, and let's say use echo greeting. So it will be echo, greeting, specify the name. Let's say Kokoda. And then, oh, why it doesn't apply? It should repeat 3 times because we have default argument 3 times, but here it's only print 1. Oh, so I think I should. The repeat function should be out of printing. This one, read, it should be out. It has to be the one which is repeating the printing process 3 times. So here, how many? Yeah, you just leave it like that and then run the function to update it. If you click here, you see it will give you how many times of printing? 1 time. Yes, you can see here. Oh, I'm just wondering. So you can see it should repeat this 3 times, but I'm wondering where is the first one coming from? Can you help? Where is the first hello coming from?
Or is it because you're using print and paste?
Hmm?
Could it be because you're using both print and paste?
And then paste. Paste is combining the 2 strings, and printing is the one which is bringing the output.
Kokoda,
Anyway, no problem. It's
Kokoda,
the modifications of the function here, but is there? No, it's not. Even the you run it again. You see? Can you see the outputs are repeated 2 times? The first vector is containing one name, and the second one is the echo. So the bottom line is here how many times you should need to echo this greeting. So in this case, we call the function without specifying how many times. By default, it uses 3, which is already specified in the function. Now, let's say you specify, you don't want to use that default value. You want to specify, let's say, 5 times or 10 times. If you run this, you will see it will print. Focus on this one. It will print hello 10 times. So you can do this with different function. Even the addition one, you can decide to make one default, and the other one you can be supplying it. So the purpose is to, in case you don't want to modify a parameter or argument every time, you can set that one, or the argument is not varying too much. For example, people who are working, let's say, in the human resources, they are calculating the salary raise or the amount of tax removed from someone's payment or the discount given to a particular product. So you can say, like, we usually provide this percent of discount or of raise, so it can be set as a default argument and modified whenever it is required or used if we don't specify.
Can you try to run it without the second argument? Just curious to see the output.
Yes, it was run before.
Without putting knowing, yeah.
Yes. It
I
will
just,
it will give you three. The second vector.
Yeah.
It uses how many times, which is 3. So the next thing, yeah, I know. The next thing we would like to talk about is about this function called source. It is built up in R, and the purpose of this function, it helps you to run the external script. So let's say you have written the function, you are performing a particular task, and you wrote some function or one function, and after some time you are doing the same task in different data set, and you want to reuse the same. You don't have to write the same function. You can use the function which you wrote before in the task you have. And in this case, we are using source to run the script which is containing that function. So what we are planning to do here is create like external file, a new file, R script file. And then here, define let's say multiplication. Yeah, multiplication function. Open the new script, please, and then call the function multiply. Then it will be function taking any two numbers. In this case is xy, and then you can now tell our product equal to x. How do you multiply in R? You use star y, and then return product. You see, if we run this, the function will go in the environment because we are using the same environment for the same script is. And I want to save the file, save it in the same, all right. Save it in the same folder. You have other script, the intro script. Functional programming, where are we? Yeah, save it here. And I'm gonna save it. Interesting. Save it here along with the other script. Let's say I will call it multiplication function. R script. So if you run this function in the environment, it will come here in the environment. And if you want to use it, you will just use multiply xy, specify any two numbers. I'm doing it on my console for quick show. So you can See, it is working. Multiply area two numbers. So now, let's say you want to use this function. Use multiply. It will be multiply. You see, oh, sorry. Yeah, there is multiply here in the global environment. I want to multiply two numbers, 5 and 5, 5 and 3. And in this case, you should have 15. So here it works because you already run the script to contain the function, and function is in the global environment. So now remove the same function from the environment. Remove the multiply from the environment. It's an object, so you can just use remove. You see it is gone from the environment function, you don't see it. Now, if you repeat to call the same function, you will see you get this error here, the console. Multiply 3, couldn't not find function multiply. So the assumption or the idea here is you already have your function and I want to reuse it in a new script, or you have a bunch of code, not necessarily function, you have codes, you define different variables and you want to use them. So what you are supposed to do here, you need to use source to get the function to your, or to run the script which is containing this function. So you just need to specify, use source and then specify the path where you store this function and the script. So in our case, it is already here in the multiplication. So you just need to specify the name, multiply. Or you can come here, copy this, and then put it in your
It's missing a part. Oh, yes.
so it seems like we have no such file in the directory. So let me see where the file is. It is multi. Oh, yeah. You need to also to check your working directory. Where are you now? Oh, yeah, in the document. Sorry. I'm gonna set this my working directory, and then if you run this, it will load the multiply in the global environment. You can see it get added here, and if you try to multiply, it works. So if this is important when you have script is scattered on your computer, so you can reference them here, not necessary to bring it in your project. You can specify the path here and then run the codes you want. So I think we are running out of time and we couldn't manage to get to the final part, which was to now write the function which is taking care of our summaries we introduced at the beginning. So
We can get that as a homework assignment.
yeah, so that is going to be your homework. In addition to that, you receive the materials from last week. There is this HTML file. If I open it here, there are reference notes because this course is not included in the website. So we tried our best to prepare these materials here. So feel free to go through them, and you will also see the example, the function, which is solving this motivation we introduced at the beginning, the summary, the TPR summary. And you will see additional contents related to other topics in functional programming, because functional programming is a wide topic. We just scratch on the surface. There are many concepts which need to be covered, but because of time and nature of the course, we are limited to this. We end up learning how to write and use functions. But you can explore for your own on your own time. We have apply, family of function in R. They are cool tools. And you can see these references at the end. You can check the references at the end.
Can you show them how to render the document? Because I'll need to present it.
Yeah. The other important thing, before opening this, you need to render the document so that you can get all the features I'm showing you here, right here. So you need to render the document. I think it was taught during the quarter. So you just need to open the source file, which is quarter QMD, and then there is a render button. Then you click there, it will compile everything. You see here, I prefer the source. Click render button here. If you click render button, you will see it will run and compile everything, including plots, chunk of codes, and the narrations. And then eventually you will get your HTML. You see, for my case, it works. So you are advised not to change anything. You just open and render. If you face anything, some error, you can post on WhatsApp group and then we can resolve.
So maybe you can go back to the homework assignment so that it's clear what they will be working on. I think you may need to go back to the slides from the motivation. So you can explain to them what they're expected to do.
So here we have shown how tedious is repetition of this blank block of codes. So you are supposed to write the functions, which is taking what is varying. In this case, you have admin 1, admin 2, you have HF. So it's what is expected to be as a parameter. In addition to that, we have also this admin 1 HS facility column and admin 2. They are coming from the data frame as a column or variables. So you need to include also DF as an argument of your function. So maximum argument of your function will be 2. And then this block of code is the one which is repeated. You can include it, you should include it on your function. The only thing which is varying is the group by. So whenever you change this, it should give you the summary corresponding to the grouping variable. So I think it is well explained in the material I just showed you. So you can go there.
So the due date for that homework will be Friday this week. You have to upload it on Google Classroom. And if you run into any challenges or questions, feel free to just post in the WhatsApp group. And your instructors will be able to help you.
Yeah, so yes, feel free to use the WhatsApp group or email or anything to reach out if you have any issue. Otherwise, if there is no any question, thank you so much for your time today and hope to see you next sessions.
Thanks, Kokoda.
Thank you.
Yes, we could do it because of those technical things. And sometimes was wasted there.
That is the challenge of online teaching. As you as professor, you have internet or technology are using.
But I think this was my computer. I don't know if it has been on for a long time. But I